In this video, we're going to talk about conditional probability. And if you watch the video on the multiplication rules, you've really already experienced conditional probability, because when you find the probability of two dependent events occurring, which is what I did in those multiplication videos, we must find the probability of the second event occurring given that the first has already occurred. So this given condition, this first thing already occurring, affects the second thing happening, and we call this conditional probability. Anytime you see the word given, and sometimes there are other ways that the conditional probability problem is written, you might not always see the word given, but I would say that's the most common way that these problems are written. You can assume that it's a conditional probability question, and the notation for that is this vertical line. So when you see this vertical line, just say to yourself, this means given that. So we read this, what is the probability of B given that A has already occurred? Okay, so A, that's your condition. So that already occurred. B is the event that you're trying to find the probability of. And there are two methods for solving conditional probability problems. There is a formula. We are not going to use the formula. We are going to focus on method one, which is where you just reduce the sample space based on the condition. We kind of reason through the problem. This is reasoning, and we are definitely going to use this one. I think it is by far the easiest one to understand for the average person. So for example one, let's look at example one. It says find the probability that a die rolled shows 6 given that we rolled an even number. So when you're doing, when you're working on your math and you see a problem where you see the word given, hopefully at that point a red flag goes off and you think, okay, this is conditional probability, so I'm going to have to do this in a special way. And so the condition here is that we rolled an even number. Okay, that narrows down the sample space. So in the beginning, we had 1, 2, 3, 4, 5, and 6. Those were our choices. But this is saying, given that we rolled an even number. So I'm going to take everything that's not even, and I'm just going to go ahead and I'm going to cross that off. Because given means, hey, it happened. So those 1, 3, and 5 are now gone. So the reduced sample space is just 2, 4, and 6. So there are 3 elements in that sample space. So for my probability, I'm going to put 3 in the denominator. So this represents the number of even numbers on the die because that was given. And then the event, so that's what we want to find the probability of. So find the probability that a die rolled shows a 6. So at that point, you look at your reduced sample space and you say, oh, well, there's only one of those. So the probability is 1/3. So, and if you want to use these words up here basically just to work through the problem. So use these if they're helpful. If not, you can just draw the picture and skip them. But the event in this case is rolling a 6. And there's only one of those. So we say there's 1, and there's 3 elements here in our reduced sample space, so our probability is 1/3. Okay, let's look at an additional example. So example 2 says the table below shows the number of survey subjects who have received and not received a speeding ticket in the last year and the color of their cars. Find the probability that a randomly chosen person has a speeding ticket given that they have a red car. So you want to look at the statement after the word given first. That is the condition. That's going to reduce the sample space. So given that they have a red car. So condition is they have a red car. We only want to look at red cars. So that means I'm going to look at the red car row in the table, and I'm not going to look at any of the other numbers. They don't even matter because we know that the car is red. And so now that we know that the car is red, we're going to consider what comes before the given. So what are we trying to find the probability of? The event. What is the probability that they have a speeding ticket? Okay, so for our probability, our condition is going to go in the denominator. So what is the total of red cars? So the number of red cars goes in the denominator because we know that that's the only group that we're looking at. So we're going to add 15 plus 135 gives us 150, and that's going to go in the denominator. So out of 150 red cars, how many had a speeding ticket? Well, I'm just going to look at this 15 because those are the cars that had a speeding ticket out of the red cars. So the probability is 15 out of 50. And then just like any other fractions in probability questions, you're going to want to reduce. So both of these have a common factor of 15. So I could divide 15 by 15 and get 1 out of 10, 1/10. You could certainly use your calculator to do that as well. Let's look at the second question. This one asks, what's the probability that they have a red car given that they have a speeding ticket? So we see this word given, we look at what comes next. That's the condition. The condition is they have a speeding ticket. So that tells us what we need to look for in terms of the sample space, and that's going to give us our denominator. So the number of speeding tickets, that's the total we're looking at. So I look at the speeding ticket column, which is right here. We're just going to look at these, and then we're not going to look at any of these. So out of the speeding tickets, what's the probability that a person has a red car? So I'm going to, and actually, you know what? I'm getting too far ahead of myself. I forgot to add those two numbers. So we're going to do 15 plus 45 on the bottom. So we're going to get 50 there. And then out of those 50, what's the probability that they have a red car? So red car is going on the top and speeding ticket is going on the bottom. So total speeding tickets. So red car would be 15. So the probability is 15 out of 60. And then I'm going to reduce both of those by dividing the numerator and denominator by 15, and that gives me 1/4 or 0.25. In example 3, we're looking at a local restaurant surveyed a group of 200 students, so that's the grand total, to determine food preferences. Each student was allowed to pick one. If a person is selected at random, find these probabilities. So what's the probability that the student chose sandwiches? Now, I like this problem because it has some regular probability problems thrown in. So there isn't, notice you don't see the word given here. This is not conditional probability. So if it's not conditional probability, then your denominator is going to be 200, which represents the total. So that's the total number of students, and then we want to find the number that chose sandwiches. So the number of sandwiches is going to go on the top. So we're going to look down the sandwich column, and we're just going to add those together. So 25 plus 28 is going to go on the top. And so we add those together, and we get 53 out of 200, and that's going to be the probability that the student chose sandwiches. And that's not, that's in lowest terms, it's not reducible, so we're just going to leave it like that. Okay, so let's look at the next one. The student chose sandwiches given that it was a freshman. So given is important. We look at what comes after the word given, and we narrow down our sample space. So in our denominator, we're just going to put the number of freshmen because we know it was a freshman, and the number of sandwiches out of that group goes on top. So I'm going to look at my table, and I'm going to figure out how many freshmen there are. So I'm just going to look at this row, and I'm not going to look at the sophomore row. So I'm going to add the 25 plus 31 plus 10 plus 15. I'm going to add those all together, and I end up getting 81. Okay, and then out of those, I find the number of sandwiches. So I look at sandwiches, that's 25. So it's going to be 25 out of 81. And that is in lowest terms. And remember, you know, if you have a TI 30 or 34, you just put in 25 over 81 and hit the simplify key if you want to see. And when you see factor of 1, that means it's simplified. Another option, if you have a graphing calculator, is you could just do 25 divided by 81 and then hit math, enter, enter, and it gives you the same exact fraction. So that just means that it's not reducible any further. Okay, so then last problem, we're looking for the probability that the student was a freshman given that they chose sandwiches. Okay, so I'm going to want to erase all of my notes from before, and I want to eliminate, I want to just look at the group that chose sandwiches. So if I look at just the sandwich group, we're looking at these, and we're going to not look at anything else. Okay, so I'm going to put the number of sandwiches is going to go in the denominator. So that's going to be 25 plus 28. Okay, so I add that together and I get 53. And then we look at the part that becomes before the given. What's the probability that the student was a freshman? So I'm looking at the number of freshmen, but just out of the sandwich group. So that's why I always look at the denominator, or what comes after the given, first. I narrow it down, and then just out of that group, then I identify the number of freshmen, which is 25. So 25 is going to be the numerator. So the probability is 25 over 53 for that one. And that is already in lowest terms, so that's my final answer.